Hello everybody, welcome to another stream. How we doing? Last stream we got the occlusion buffer plugged in and working, and it went quite well. In today's stream we're going to be fixing these Z ordering issues. We have two ellipsoids which are on the same, which are overlapping, and when they overlap they're not quite in the right order all of the time, because they are sorted from front to back, but they're sorted from front to back based on their front position of their axis line bounding box in view space, which leads to, oh, there's some bit glitches there, right? Which leads to, depending on the orientation of the camera, different orders. So, well, the ordering needs to actually happen per pixel. So we've already got an ordering, which is good enough for the view, but we're going to have to change the ray tracer a bit just so we can make sure per pixel that they are actually sorted correctly. So we're going to do a little bit of a hack to get that working today, but there is a bug in the occlusion buffer code, and I'd like to fix that first. Can we see here how there's things disappearing? Now I think that it must be to do with the occlusion color. Well, if I press U, isn't it? Yeah, if I press U, it turns off the occlusion culling. So I think we're sampling from the wrong MIP level, because I was thinking through the code the other day while I was like washing dishes for some reason, and I was thinking, wait, hang on a minute. The previous place where this code came from had a full resolution MIP level at MIP 0, whereas our occlusion buffer in this one is at half resolution. So when we do our MIP level selection, it's actually going to be off by 1. So I think that's what's causing the problem. I just saw the problem here now, but I knew the problem existed, and that's what I wanted to solve first on stream today. But I hope everyone's having a good day. So yeah, we go to the shaders.c file. In here there's an is occluded function which returns true if it is definitely occluded, and it returns false if it's maybe not occluded. So the problem is this function here, this one here, this line MIP equal, wait, cool. MIP is equal to, this would be like a round down to nearest power of 2, basically. I think we need to do a round up. Let's do the quick maths. So say if we have a resolution of 16 pixels that we're rendering at. Just let's keep it small so the maths is easier. Why don't I see the... Ah, there we go. I think I must have run updates. I don't know, I've not used it on this computer yet, since my latest Arch install. So oh no. Yeah, so we can use that maths, I think. All right, let's just test it out. So imagine we got a resolution of 16 pixels. Very small, but it's just an example. And then we have a largest dimension of the thing we want to test is occluded. So it's a box. It's like a axis line bounding box on the screen. Let's say that's 4 pixels. Right. So we get the most significant bit index, which will be 2. Right. And we go and that's the MIP to where it's going to be a 2 by 2 on the screen. So, well, I think it doesn't matter if it's 16 pixels or not. It gives us any resolution, maybe. Right, we'll see. So, if it's 4, the largest dimension, so that gives us 2. So if we take 16 and we shift it right by the MIP, which would be 2, that gives us 5. How does that give us 5? Because it's all in damn hex. Hang on a minute. Much better. It gives us 4. So I guess we could draw this out. Yeah, maybe we'll draw it out so we can just see it visually a bit better. I haven't even got Krita, damn it. Yes, all of those things. Right, thankfully, we can still download the pack. Oh no, it can't. I think it's SYY, isn't it? Ah. Hopefully that's it. There we go. Arch Linux. So, if we open up a new image again, so imagine the resolution rendering at 16 pixels. And then, oh my days. Get a paint bucket. Oh. Right. So imagine if we would like to I guess we use the brush tool and we'll do white. And I want to do the pencil one, wherever that is. So it's like hard, basically, you know what I mean? Pixel art. Oh yeah. So let's say we've got a 4. The thing I want to check occlusion for is something like this. It's a 4 by 4 block on the screen. We want to check to see if it's, this is how big it is on the screen. And we want to see if it is definitely occluded or not. Hey, kept paying. That black pencil too probably might be wrong. Yeah. Yeah, pixel art, that's what I wanted. How are you doing, Kat? Good to see you, my friend. So obviously in a real world example, this base texture will be this, you know, like 1080p or whatever. Or be half of 1080p if you're at 1080p screen, because our occlusion texture is half resolution. If it's 4K, it'd be half of 4K, it should be 1080p, blah, 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 blah. So if we see this is the bounding box of the object and we're trying to say in screen space, right, the screen space bounding box, so it's going to be a rough bounding box. The ellipsoid might take up it'll take up a small region of this bounding box, obviously. And what we're trying to say is, what is the MIP level that we need to sample at to get this to be a 2 by 2? Right, so we got 4. Yeah, I think the maths is quite wrong actually. So we got a 4. So if we do the most significant bit that's set, it will be MIP. It will be bit 2. Minute with the number of MIPs. And so we'll take 1, obviously. So when we're looking at that, so if we half this once, then half it again, that's only going to be a 1 by 1. So it's not really a 2 by 2. Right, so we're already wrong there, I think. You know, even if this was like a 5... Yeah, it's a bit weird, isn't it? See, if it was a 1, that would make sense, right? So you've got a... You'd take this 4 by 4 and you'd half it, then it'd be a 2 by 2, wouldn't it? So that's already kind of wrong there. So I think you'd have to do a take 1. Right, so then if you half this in size, it'll be a 2 by 2, and that's what we want. Now, also what's we've got to take into account is that the occlusion texture is half the resolution of the scene. So it already is taken away by 1, maybe, shall we say. No, it already is if we were selecting MIP levels for this scene that we're rendering to, it would already be at MIP 1. But MIP 0 is the equivalent of MIP 1 in a sense, right? So our occlusion texture is half resolution. So you can think of it starting at MIP 1. So because it starts at MIP, yeah, so how do we need to write that logic then? So I guess you just need to do a takeaway 1 on it. Like another takeaway 1. Is that true? Well, no, or do you really? Because no, I think no, I think this will do. I think this logic works fine. I think it was just missing the takeaway 1. Yeah, so I think that was just wrong. Let's give it a run and see if it fixes that bug that it was having. I'm doing good, man. Lots of days off because of snow days, and I'm observing observance day due to the president's passing away. Oh, what president passed away? Snow days. Interesting. Was he currently travel too well? Oh my days! Look at that bug. Oh, that's horrendous. Yeah, so an occlusion texture looks like that. Right, do we take the largest dimension or do we take the smallest dimension? No, you take the largest, I think. Yeah. Huh. So I wonder, what should we test then? Oh, crap. I just realized this is occluded is called. Right, so when it builds the occlusion buffer from the previous frame, the resolution is going to be different. You know, maybe what we'll do is let's just render the occlusion texture in full resolution. I'm doing it to save some, increase the performance, but it's making it more buggy, and I'm gonna have to do a lot of gymnastics, I think, to fix some of these issues. So let's just even it out, because we're reusing the same code for the occlusion render, which also does this is occluded thing, and we're passing these sort of scene dims here, which is actually the wrong resolution for the occlusion render pass. So how about we go into the occlusion texture, and rather than to do investigate running the occlusion buffer at half resolution. Yep. So for now, let's just try that. And that might be what we're looking for. Oh, there's even more problems. Right, so even the occlusion texture's missing, because it's using the occlusion texture from the previous frame to do its testing, which is interesting. Oh, that one took even longer to run. Oh my days, look at that. HP 0.11 or something. Yes, it's 4 times slower, of course, because it's 4 times as many pixels, right? Yeah, maybe we do just do it half resolution. Right. Yeah, maybe let's... Okay, what I might do, because this seems like it's going to have a bit of investigating to do, is why don't we try and solve the problem that we will set out to solve today, and then if we've got time at the end, we'll look into this occlusion buffer issue, because I've already got this problem solved in my head for the plan today. So I think if we execute on that, it should be a lot smoother, and then we'll come back here and yeah, get a win hopefully. So I think we found some issue with it, but it's still problematic. Cool. So what we're solving today is as follows. Currently when we render, we saw all of our ellipsoids into screen tiles of 16 by 16. We might change that size at some point, but for now it's 16 by 16 pixels. It might vary based on resolution. So that means every time we try and render one of these guys, we put there's a little array of ellipsoid indices that have to get filled up for each tile. So essentially we're duplicating these ellipsoid indices as many times as there are tiles that it goes into, and then we are sorting all of them with the tile coordinate in the high bits, and that's how. Oh, and then in the low bits we've got the depth. The depth of, if you was to wrap a bounding box around it, this depth, so essentially the length of a line going from the camera's origin to the front of the bounding box. So in a very ideal world where you don't have any overlapping ellipsoids, this works perfectly fine. Or even if you have overlapping ellipsoids that don't poke through the front of the other one, you know, and if it's spheres, I guess you're less likely for this to happen. But the really like odd shaped ellipsoids and orientations of them, you can end up poking through another one. And if you just sort so these ones are okay still, because again, the front bounding box is still okay, right? It's still in the right order. So when I go over all of the ellipsoid list inside this tile for all the pixels in here, all of the rays are going to hit this one first. But if I have something like this, where it pokes through, depending on the camera's orientation, the view space bounding box will be different, right? Remember, it's view space, so it's always aligned to the view. So if I rotate it around like this, well, that's a better way of saying it. Like this, view aligned would be a bounding box that looks, oh, I've got rid of my ellipsoid, haven't I? View aligned would be an ellipsoid which looks like, sorry, bounding box which looks like that or something like that, I think. And it all depends on which one has the furthest forward one of these axis line Z coordinates, right? So it ends up meaning that things which are overlapping and sort of poke through each other will have slightly different Z orders. And even if you look at it from this direction, right? You've got this one which is clearly in front, right? So this one will be sorted in front. And then this one which is behind that one would be second, right? The one that's part of this big wall. Well, if you shoot this ray, sure, that's the right order, right? But if I shot this ray, well, actually, wait a minute. No, because it missed this one, that's okay. Yeah, so it missed that one. That is correct. And then it would hit the one behind. Yep. Okay. So that's an okay situation. What was the other one? Yeah, so I guess it's just when you move the camera and the bounding box orientation or shape changes. Okay. Is there another case like this? And I guess it gets even worse with transparent objects. Yeah, because you'll just see it a lot more, basically. Okay, so the way we solve this problem is we've actually got to Right. So I was thinking that means per pixel we've got to sort it, but is that true? It definitely solves the problem, right? Because if the ray... Oh, yeah. It definitely solves the problem. Because... So if you have another ellipsoid which is going through like this, right? And if you shoot a ray which hits this thing, well, as you've turned the camera, this one might not be technically in front when we sort it based on the axis line bounding box, because this other one has a bigger bounding box overall, right? It has a more square one, whereas this bounding box is more rectangular in this 2D case, right? So as you reorientate the camera, it could mean that this bigger one, which is like more of like a square looking one, will actually get put at the front of the list for the tile, but it's actually for the tile that we're rendering. But actually the one which is in front technically is this one here. So we've actually got to accumulate all of our hits, and there's a little trick we can do to early out still. So we don't have to, when we shoot a ray, we don't have to be like, have I hit this, have I hit this, and have I hit this? We could do a little trick to say, well, as soon as you've hit this first one here, or the one in here, let's just say it's this one here, you go right. So you do the next test, which would be this one here, this circular looking one. You do that here and you say, is that depth behind my closest, but behind my current opaque hit? And if that is true, then you could early out, I think, but maybe you have multiple overlappings. Right, you might have to say, is... Yeah, that still might get a glitch, actually. You might have to say, is it behind my far exit point? It might have to be that logic, which would be a shame. Because you could have some other ones which are... Or behind my middle point, at least. Maybe the mid. Let's think about that. Yeah, I would say the middle depth. Okay, maybe the front one. Let's see if the logic is true. So yeah, say if you had like a few ellipsoids overlapping each other like this, and you shot a ray, and you hit this one. So you get a depth for like here or something. And then you would test the next hit, which I guess would have been this one. Yeah, but you don't know what order there would be in. There's 3 of them overlapping. You've got to test all 3 of them, basically. You need to, because they're overlapping. So I guess you've got to use the far point. It's going to be horrendous, but okay. Right. Let's run up the code. So we'll start off with the ray trace anti-aliasing version. So, you know, we've sorted them into these, so our list per tile. A tile is 16 by 16 pixels. So here we're launching an 8 by 8, and that reaches into a 16 by 16 tile. So there are still some optimizations we can do in this shader, like preload into some thread group memory or something. But for now, we've just got a version working with anti-aliasing and everything. So what we need, so this naive approach of just going over all of the ellipsoids and breaking when we hit an accumulated alpha of 1 isn't going to cut it anymore. So what we're going to have to do is do another step before. So this generates some kind of hit list here, actually thinking about it. That's interesting. And then it does the shading afterwards. Right. So what I would like to do is still generate the hit list, but... and then we need to sort it afterwards. So we want to build up a list of probably 3... I forgot what I settled on. 3 transparent objects, maybe, and then a 4th opaque object. And that way we can support a good layer of transparency, a good number of layers of transparency, but and still do some level of sorting in a shader, single threaded, which is not ridiculously expensive, right? So I think we'll try that. Because we'll sort basically 3 objects, you know, you just look over them and do a quick naive sort. And that should be okay. Maybe we can do 2 layers, but maybe we could do 4. We'll see, we'll have a bit of a play around with it. So maybe we'll keep this rasterization step. But we want to be able to... so we want to generate a hit list. So this keeps the depth and the normals. See, the other problem that we have is that we have anti-aliasing, which is based on a hit, which is at the end, and the way we tell it at the edge, and the way we tell it's at the edge is because we look at the hit normal. Well, what happens if we just right, so let's change this a bit, yeah? So we only need to extract the depths, the normals, the depths of each hit, the normals, and the hit list. And the hit list contains an 8-bit integer for each of the ellipsoids that we hit. And I guess that could be a problem if we have too many ellipsoids in a list, but yes, there's 4 of them in a... oh, no, they're full fat U32s. Okay. Interesting. Cool, but I think in one of my other ray tracers, I do pack them down into 8s. So we could probably keep this code, but just remove the accumulated alpha. Now my question is closest hit. Yeah, do we include transparency in that? Maybe we need 2 depth buffers. That's a thing for the future, I think. So we'll move this accumulated alpha thing later on, because that could make us early out on the material shading stuff, right? So we'll move it into there instead. So when we go over these, we've got at most 4 hits, 3 opaques, sorry, 3 transparent ones and 1 opaque at most. So we go over all, we keep going. Right, do we care about the alpha at this point? Right, we shouldn't be calculating the, oh no, we need to calculate the anti-aliasing alpha, isn't it? To know whether or not it's a transparent hit. Yes. So we do all of this stuff here. We do our reverse ellipsoid. calculate the normal. And this is where we go. So I guess we say if this one is transparent, we'll say that this is a transparent hit. Now we should probably say minus epsilon or something like that. Some very, you know. Maybe not. Maybe. Because we're like multiplying it here, and maybe we should do 0. Something like that, okay? So this one's saying that it is transparent. So if it's transparent and we've hit and we've got so this just essentially adds to the hit list. This closest hit thing's a bit silly, not gonna lie. We could just look at is that the thing that's just sent out at the end? Yeah, it's a bit dumb. We've already got the hit depths. So we can get rid of that as well. So yeah, this is just essentially inserting into the list. Cool. Right, so the alpha is packed into the end. So we've got a 24-bit number. Okay. So we take that alpha and do a test if it's transparent. We only want to insert it if there is basically less than less than 4. Or less than the capacity, shall we say, because we've got constants for that, right? So why are we just putting 4 in there? And then if it is opaque, we only want to insert if we haven't already found an opaque hit. Now, so I think we want to say, what is the opaque hit index? And we can start that off at E32 max. So we want to say only insert this one, providing that opaque hit index is not equal to E32 max. Now, this is where the tricky, so that this can work, right? So if we have like 3, as soon as we have more than 3 transparent objects, the ones which just, the ones which are, after we have like 3 layers of them, we just stop accepting them. So if you have 3 overlapping ones, you might see some bugs. Now, or maybe we have maybe we don't put the opaque one in an array. Maybe we put in its own separate variables, but then it won't be able to get sorted with the rest of them. So now this will allow you to do an insert like this. But if we couldn't insert, and this is an opaque hit, that would then mean we need to test whether or not we are the closer and if the hit list opaque hit, there's a depth, if that is greater than T near, which is the hit we've just done, closest hit on that. And if that's true, we are now the new opaque hit. So the opaque hit T near, normals will be the closest hit normal. I don't know why I call it closest hit. It should just be called hit. Right, it's silly because it's just copied from other code and I've just kept the name. So then that will accept that I'm the closest. Now I don't know if we're going to get some odd logic here where, you know, this is going to return false and this also returns false. I sure hope that's not the case. But we'll see. Alright, bit of a copy-paste bug there. Okay, so now we've made this so rasterize the ellipsoids, find all the ellipsoids we hit and generate a hit list. Excellent. So that comment still applies. Now this is where we do a new thing. Now we want to sort the hit list in front to back so that it is definitely front to back for this pixel. As the front to back view bounding box, view space bounding box sorting is not 100% correct. And that's where the bug is coming from. So we've got 4 entries to sort, single threaded. So we just got to do a bunch of swaps, right? I guess what is the best algorithm to do that? I don't know. So we don't have to sort. So the thing is though, right, so we're going to do it in a single integer. Sorted hit list. Single integer because there's only 4 entries. Right, all we need is, we only need 2 bits. To represent 4 values, right? So they'll definitely fit in a 32-bit integer. So if we simply just, so should we do it packed in an integer, or should we do 4 separate values maybe? Because this is like an index into the hit list. Maybe should we do it packed? Could there be any sort of interesting stuff we could do with that? Because you get to sort of shift things around, right, when they're packed. But you don't necessarily get to do, but all we really want to do is put all the values out and then probably swap them. Right, that's all we really want to do. And you're not really going to get any way, because you still got to like mask it out, and then you've got to, I guess you would like, Yeah, there's not really... Let's just use the extra registers, we'll see. The only thing you'll save here is some registers. I don't think that's the problem for this shader. So let's just say there's a sorted hit list. And let's just do it as an array for now. We can hyper-optimize it later. But the packing the bit set doesn't seem to be that beneficial. So when we go over this hit list, we've just literally got to go over the depths and figure out, hey, which one's the closest? And then which one's the second closest? Which one is the third closest and fourth closest? And somehow... So the sort of... Right, best sorting algorithm for 4 numbers. See what Google says. Yeah, I think the Bitonic sort does something like this. Is this what it does? Split into 2 sets, A, B. The thing is, ours is not always 4, but we can make it always 4 by literally sticking a high number in the values which are not set, and then it will sort correctly, right? So that's interesting. So take numbers A, B, C, D, split into 2 sets, A, B, C, D. Order each of the 2 sets, so you get E, F, G, H. That's 1 comparison per set. And now pick the lowest, right, and then you order the sets as a whole. So that's 3 comparisons. Compare the last 2 elements. You might not need to if this step... No. Why do you need to do a 4th one? Yes, you can compare E and G. Oh no, you will have to sort them. Yeah, you would still have to do that, isn't it? Oh, yeah, you would. Crap. Then you do E and G. Or F and G, right. EH or F and G. That's 4. Right, so I guess... Oh my days. That's not a bad way to do it. That seems pretty legible as well. And it's just code that it can just... Yeah, it's code that can just be executed. The problem is maybe... that branching code would be horrible. So in 5 compares you can do it apparently. Yeah, so I might do this one because it just seems... Oh, this one here, this seems pretty legible. You can read it, you can understand it. But I wonder if there's a better way to do it. Right. Let's look at that. There's the other one. It was like the Bitonic sort. There was a... This was good for power of 2 numbers, wasn't it? but I don't know because it would sort. Yeah, I think we just need to just do comparisons, honestly. I think that'll just be the best approach. Right, let's just do this. So we'll build a little swap function. And maybe... Okay, so if we take a look at these depths, if we initialize all those to infinity, then we should be able to right, so if we look at... Yeah, but how would we even do a swap? You know, we'll just do a define. Hey, machine knob. What about pure pure mathematics sorts? I think it should be possible, but of course I have no idea how. Right. What do you mean by mathematics sort? What does that mean? With pure maths? How would one sort with pure maths? So sorted hit list. So I guess we'll initialize it to 0, 1, 2, 3. So you'd say, I guess we'll define a quick TMP. Then we'll undef it. So it'd be a TMP equals a sorted hit list. B is equal to, or A is equal to B. And then B is equal to temp. Something really dumb like that. So effectively we're just going to say so we'll copy that logic. Seems like the easiest one to do. But the problem is that's going to change what entry it is because they take addresses and stuff like that, isn't it, right? Oh yeah, but we just have to do sorted hit list. Oh, this is a bit dodgy, isn't it? You would have to do if 0 and then hit list depths. Yeah, I don't know how good this is going to be. Then you say, hey, swap swap 0, 1. All right, we could do that. So I guess I can make this all big one macro thing, right? Compare, swap in, compare, maybe swap. And then you would just do this whole thing. Oh boy. Alright, so I guess we'll pretty this up a bit. As much as you can, the macro, right? A, B. So I guess I can now declare this locally. And voila. So I guess literally we just do compare, maybe swap 0, 1. Then it says 3 and 4, so you do 2 and 3. Done that one, and then be 1 and test, sorry, 0 and 2. Then test 1 and 3. And then test 1 and 2. Alright, apparently that's it. So after that you get a, you know, it's a super specialized sort for 4 entries. Even if we don't have 4 entries, we've initialized the depths to infinity, such that the ones which are uninitialized would just be at the back. Neat. Okay. This is workable. I'm not sure about performance compared to ifing with a swap, but something like this. Interesting. I see a square roots, that's a bit scary, not gonna lie, but if they're constants, maybe. Right, so I'm gonna put it up on the big screen. Right, so you're saying pure min. Float x, pure max. Right, I see what you're doing. Right, this is an interesting take. You give me ideas. Because all I need is the depth and an integer. I could pack the depth down into 16 bits. But there will be precision problems. I could pack it down into 24 bits, and all I need is 2 bits anyway. I could put in the high bits the depth, since it's the most important bit, and then the low bits put in the and then I wonder, would you yeah, then you could probably do some mins and maxes, isn't it? But mins and maxes are basically if statements, aren't they? And then selecting one, or it's a select instruction. So you'd be doing some packing, doing some select instructions, and then after that, you would You take a min of the first. Two min of the next two. Yeah, I don't know. I think let's just stick with this. But yeah, see, there are other ways. Maybe we could do it with minning or maxing, whatever it is. Yeah, perhaps there is another way. Because that might yield better performance, maybe. We'll see. To do, see if it is better to use min to pack depth into high bits and hit list index into low bits and sort by using a bunch of min-max operations, something like that, right? Yeah, that's the other approach, isn't it? Cool, I'll think about that. Right, that's interesting. Okay, so now we've got a sorted list. Now, when we go over and do the material shading pass, accumulate alpha equals 0, so we've moved it down here now. Final color. You've got to index into the sorted hit list array first. So now we do this sort of H index. That would probably be called UH index. H index equals UH index. Looks like sorting network. What is that? What does that mean? Yeah, so pure arithmetic way would probably be too slow performance because of square root. Yeah, definitely. That's okay. But that's how you figure out new solutions, right? You think about different options, even if it is the slowest one, or learning about someone else's approach, because they can actually help you think about a better solution anyway, right? It's just different perspectives. Like you've made me think about maybe we could do it with min-max operations. That's possible. So there's a good, I'm glad you told me about it, the way you thought about it. I remember it from sorting class, optimized sorting for like 5 ints, right? Sorting network. Oh, it's got a term. Right. Oh, interesting. Right. Number of inputs for size and depth combinations, min size bounds, min depth bounds. Yeah, so I guess it's like they can do it like branches and things or trees or whatever. Right. I'm vaguely understanding it. Alright, Vitonic, that sounds familiar. Yeah, I see. Yeah, so I think that maybe this is what we might have done. I don't know. But yeah, I see what it's saying. kinda. But yeah, I'll write that down as well. Sorting networks, that in quotes because I won't forget that, is also something to look into. It's a hard-coded number of values. Right, thank you for that. Appreciate it, sir. Cool. So, sorted hit list, and then we get it in the sorted order. Nice. So this is where we get the alpha. We extract it from the hit. Now, we want to generate some accumulate alpha. Anyway, it does the shading. Front to back blend. We don't need to accumulate alpha anymore because that is in the color. So all we have to do is say if final color.a is opaque break. So this is where we might. So we only support 3 transparent objects. So yeah, what happens if you don't hit an opaque and you've hit 3 transparents? So we will just not accept any more transparent objects, even if we never hit. So we could say accept 4 transparent objects, right? But then if there's an opaque hit, so I guess you say less than or equal to that. And then what you're saying here is, well, on an opaque hit, we could go right. Opaque hit index so we only insert providing that there is room. But then it's that depth thing, it's just silly. You know, let's just keep with 3. Keeps it easy to. The maths is a little bit more, or the logic is a little bit more. Well, there's a little bit more in this other branch, and I'm not happy with that. Let's just say there's only 3. Okay, let's just stick with that. Cool, so I think that's it. So I guess let's try this shader out. Oh, closest hit to T. Well, we probably only want to render out the opaque hit index. Now, if there isn't an opaque, then it's still infinity, I think. So we want to say closest hit T or whatever. That it is equal to opaque Brajan, thank you so much for the Prime sub. Appreciate you, sir. How are you doing? Thank you for the sub. I wonder how early to do it. Well, you still use the depth, isn't it, here, right? Yeah, so I guess it doesn't matter. Yeah. Well, you would have sorted it, isn't it? But you don't know which one is the opaque one. Yeah, so you would say hit list depths, opaque hit index, if not infinity, float 32. That'll be alright. Cool. So we only output as actual depth information an opaque kind of hit. Or it might be nice to say, well, when it reached opaqueness, that's the depth I'm outputting. That would be interesting, right? When I reached a level of opaqueness, that is what I deem a hit. So that would just be depth. Nice. I like that. So, you know, I think some algorithms might want you know, it gets a bit, it depends how many sort of like, or what you're doing with the buffer after it's been rendered. We'll see. We might want to have two depth buffers, one with the closest transparent object, one without it. But for now, is to do it without it. Cool, so hopefully that works with no problems. We'll see. Well, this looks very... We've just made an anti-aliasing renderer. It just renders the lovely dusty edges. Isn't that lovely? It's an outline renderer with a little bit of dust on it. Okay, well that's clearly a problem. I wonder if it's to do with this code here. Let's start by not doing the swapping and just see if it's to do with anything to do with the collection of the... Right, still a problem. Right, so I guess it could be to do with this code. So we would actually not... Oh. So we didn't do the early exit. So it is going through all of them now. So I'd like to think the performance is terrible because we didn't do the early out. Oh, that performance is terrible. 2 milliseconds, it used to be like 1 point whatever. Okay. We only want to render opaques providing that there is nothing in the list. Or we insert if there's nothing in the list already. That was the problem. Cool. So we don't do the early out, so we'll do that and see the performance increase as well. So here we go. Let's just see this working. It's still fighting, which is a bit weird. What are you doing, mate? I thought I would have solved the... Oh, we commented at the sorting code, didn't we? Right, so let's re-enable the sorting code and then we'll do the optimization if this works. So we've got an occlusion buffer bug, which we're hoping to fix after this if we have time today. If not, it'll be in the next stream. Right, this looks horrible, but it's kind of sorted fine. Right, I turned off the occlusion buffer, so we're now kind of. There's still some issues with the normal. But we're getting, things are not really popping in and out. Sorry, being rendered in different orders, if you will. but there's something else which is painfully wrong. So the ones which don't overlap, basically, those ones have issues. Why? The ones that don't overlap have problems. So those only have one entry. Is that the issue? So your pack and entrance there, we can do some debugging and stuff. And then you're going to get what? A normal. Like we've got some print stuff that we can do and whatnot, but let's just have a bit of a gander of what's going on. This code is definitely not running, but let me just double check this. If the depth is further away than that, yeah, then insert over, that makes sense. Oh, the hit list T itself did not get updated. That can't be the issue. What are we packing there again? Or it's like a full-on one of these. Interesting. So if that's the case, this is really an insert index thing. Yeah, but and also that's like a third transparent one, and you've already put an opaque in there. It's not going to do a fourth. Yeah, that's a bit weird. Okay, we've got to sort that out. Oh my days, this logic. So what we probably want to do is devise some kind of insert index. And then whether or not this gets incremented is probably to do with the thing up here. So ultimately, this is all the same. Right, so we got to do some. Let's see if it's opaque. I guess you're in here then. So instead we're going to have this sort of like insert index, and we'll just put it to U32 max maybe. Or maybe we will just... Right. So for this one, let's just say we want to insert, providing that there is room. So if there's room, then insert index will be equal to whatever this count is here, and then we'll basically add 1. Now, if it is opaque, then we will if there hasn't been one that's inserted yet. See, I guess the question is, right, is there room? No, because if it's opaque, you only want to have one insert. Okay. If it hasn't been inserted yet, put it in. Probably, I hope there's a better way to write this logic because it's very branchy and conditional and horrible. Right, and then if it's insert, right, so let's read this out and see if we can improve it. So when we get a hit, if it's kind of transparent, then we're going to be like, you can only insert one into the list if there's room. And we up that. If it's maybe I could do a bit of OR logic here and share some of the right, because that's basically what we was doing, yeah? Oh, I think that's going to be it. That's good, that's better. So we're saying if it's basically transparent or there hasn't been an opaque hit yet, just check if there's room. Wait, that's it. Just check if there's room, chuck it into the end slot. Nice. If not, we got to do another if condition here. Unfortunately, you need to say if alpha, if it's still an opaque, we're saying if it's an opaque hit, and yeah, but which one of those failed? That's the problem, isn't it? All right, so maybe the condition should be, oh, this is a bugger. Or you're saying if the opaque, so you know one of those is true, but which one, right? Maybe, maybe we put the branch back. Right, I think we can do some pretty wacky stuff. I think there's some hacks we can do. If the insertness is less than that, right? So what we do is we can remove a lot of these branches because the branch will happen later. So I think what we can say is we can just say if it's transparent, just say it is. And you can always run this code and you say advance it if this is equal to that. I don't know. So now all we have to do is define the insert index in some way. Maybe that helps remove some branches. So if it's transparent, we want to insert, we want to set insert index to that. And then what we're saying is if it's transparent or if there's not been an opaque hit set yet. Yeah, but then that will mean that you don't overwrite the one at the end. That ain't gonna work. Right. So this one with a min U32 and the capacity. RTAA hit list capacity take 1. So you always want to guarantee that it gets a slot here. So we say like overwrite the last entry if the array is full. That's what's different between this one and that one. And then this one is saying only if the depths. So it's not opaque. Sorry, if it is opaque and there has been an opaque hit. If our depth is closer, then we'll insert there. Okay, so that's a bit better. We're doing less of these checks basically, right, in each of the branches. So it should hopefully be just a little bit better. And I think that's the best we got. And I think that solves all the problems. So we're saying if it's transparent, try and put it in the list at the end. If it's opaque and there has been an opaque hit already, overwrite, try and put it in the list, or if not, overwrite the one at the end of the list. And then this one is saying, well, there was already an opaque hit, so we're going to find where the opaque hit is, and then if we're close, overwrite that, because you only need one opaque hit in the list. So this will also allow for transparency to come after an opaque hit, because they might be sorted. Not. Yeah. Right, I think that's good. So then we're saying here, increment the count if the insert index plus 1 is equal to. No. Why is it plus 1? If we're trying to insert at the end, right, up it by 1. That's good. And then we just insert the insert index and cool. So I think that's improved logic there. So I don't know if that fixes that bug that was encountering with one element. Sorry, when we had one hit. Seems like there's still that problem. So if we've got one hit, it's a bit of an issue. Is that correct? Seems so, right? Yeah, it's very strange. Could it be due to the sorting code? If I commented out the sorting code, does that problem persist? Right, sort code is wrong. This is the occlusion buffer being a bugger. That's okay. Right, so something wrong here. I guess I can double check that place we, took inspiration from, as we do. So these are 1 based, whereas ours is 0 based. Right, so 0, 1, yep. 2, 3, yep. 0, 2, yes. 1, 3, yes. 1, 2. Right, so that seems all right. So let's double check. Well, there's anything seemed correct there. So if we put AB, so depths. So the hit list is equal to 0, 1, 2, 3, yep. If that depth is greater y greater. Well, we're saying if it's less than, right? Surely. So what was happening is there was an infinity approaching. So it was getting sorted to the back. If there was only one, I think. Something like that must be what's going on. I don't know. No, it is the other way around, isn't it? That must be that way. So you're saying, hey, if A is further away than B, B needs to be put where A is, right? Because A is closer. Yeah, that's true, isn't it? Yeah, of course it is. So you put A in a temporary, B goes into A, and then B gets set to the temporary. So what we can do is a bit of a test. We can just say, right, if is mouse at, then we'll print out the sorted hit list. GPU hprintf sorted hit list equal 1, 2, 3, and 4. So I guess we just spam this a bunch of times. Nice. So we'll just put the mouse cursor on the screen and that will print out for that pixel, and voila. Two, 3, 0, 1. Odd, isn't it? Why? Oh, because they're zeroed, aren't they? What's a melon? What's a melon? They need to be set to infinity, right? That's not setting all of them to infinity, is it? You send the first one to infinity, and the rest to get set to 0. Cool, so now all the entries actually initialize to 0. I'll do it. There we go, look at that. Let's remove the occlusion culling. So now we're not getting any of the... Oh. See a bit of a problem still. Still some slight issues. That's the opaque hits, isn't it? We're not earlying out, we're testing all of them. Okay, that's interesting. I might never set an opaque hit index. I aren't. Yeah, what a melon. So I never set opaque hit index. So that will be insert index at this point here. So the other code wasn't even running. Right, turn off the occlusion culling. There we go, that's better. So when I initially made this model, right, I know it's the best model ever. It's just got a hat on the head, but I think it was actually the other way around, so I don't know what the problem is going on there. We've got other sort of test models, but this is the only one I ported to the new renderer for now. But this seems to be correct now, which is great. So now we're going to look at the performance. We've made it horrible performance, right? So the only way we can test stable performance is if we were to just leave it here and then press F4. So it's 2.5, yeah, 2.5 milliseconds there if you look at the orange bar for the ray tracer here. So if we take that one, Now here's the optimization. We have to test every ellipsoid that overlaps, because you could find a closer opaque hit, right? So the bit of code that we need to say is, if this is an opaque hit, no. So there's a T far here, which is interesting. So what we want to find is far, excuse me. So we want to find the opaque hit far. So we'll set that to infinity. And then what we're saying is, if you hit something which is opaque, you begin this sort of like phase where it could end early. So you say opaque hit far. So we haven't inserted one yet, is equal to T far. So T far is, if you take an ellipsoid, right? Let's say you hit this ellipsoid with a ray, you get two T's across the ray, near and far. So what we're saying is, we're recording this distance, right? So if there is an ellipsoid which we hit, which is after that, then we've definitely handled all the overlapping ones. So there's no more closer ones. Now, my thinking is, yeah, I think that's the safest. Maybe there's a way to make it better. So what we're going to say now is, if T hit near, so this is the early out, if T hit near is less or is greater than opaque hit far, or equal to, I guess, then we're probably safe, I think. I think that's a good metric. So we can early. And that will mean that should bring us back to the performance we basically had before. We're getting some glitches here now though, so it's a bit questionable. Now it sounds about 1.5 milliseconds, right? But this is really bugging crap out. So I think it's not really a good metric then. Oh wait, was that the occlusion buffer? There might have been the occlusion buffer. But I did just see some other little odd glitches around the edge of the edges. Right, we'll press... Right, it's not the occlusion buffer. I'm also seeing some sort of odd glitches here. And I wonder if that's to do with this logic here, you see. Oh, wait a minute, of course, if it's a miss. No. I don't know. That's the problem with this RTAA, the overlaps, you're not going to get AA'd. It will do the edges like that. That's a nice AA there. If I take a screenshot, we'll be able to see it. So the ray trace anti-aliasing uses the normal. So that's nice there, yeah. But then like, this here is horrible. So I guess that's just the, you know, it's a cheap anti-aliasing algorithm that I just made up, right? I just made it up. So if you want a proper one, you've got MSAA, or you've got super sampled anti-aliasing if you've got a beefy machine. Right. So maybe that optimization we cannot do, which would be a shame. So I don't know what other metric we can use. So the T-far isn't enough? Or I guess you got to say your T-far is... If my T-far is further than... That's the near... So if you hit this one here, that's the near, that's the far. The far is always... You know, if they overlap, the far... Yeah, so if the near is past this far hit, then it should be okay to stop searching. At least one thought. Oh crap. I see a problem. So the problem is when you have a tall and skinny one like that. You have one like that. I think. Yeah, I think we're seeing issues on this sort of like, you know, the far exit. It's quite early or something. But then why would it render the one at the back? Because maybe it hits the one at the... Maybe it hits this one first. This ellipsoid first. And then with this... So that means the far... The opaque far hit would be here. If the camera's coming from that direction or something like that. The far would be there and your near would be here, so it'd be closer. Yeah, that would fail. That would still accept it. Oh, you only really want to do this break providing that. Or it might be because of this condition wasn't passed first. Okay, we'll try that. That might be it, hopefully. Because it's a good optimization. Ah, still got a problem, isn't it? The fact that it blinks is a bit weird. Yeah, see, we're getting it there. Let's try and find a good one I can point out. We can see them here, basically. That one there as well. So it's early out when it hits this one here for that pixel. And then not hitting this one here. Yeah, so I guess that's not enough, which kind of sucks. You could take the distance of the ellipsoid. I know what would you do, right? Would you project it across the vector of the half extent? Sorry, we'd use the half extent and project it across the ray vector. And use that as the distance, as the sort of final distance to early out on, you know? I'm not sure, what would you do? So the problem is getting that half extent is in local space. You got to bring that into world space and then project it across the ray. So that's just involves a transform, but we already have the transform, so it's possible. Well, from ellipsoid, it's right here. So we could run this function and do this maths. This one, project it across the ray direction and produce some kind of like extra length from. Might be enough. Anyone have recommendations for OpenCL learning resources? No, I've actually not learned OpenCL. I know that most people try it. Most people like using CUDA, but you have to have an NVIDIA card for that. I'm not sure what OpenCL is like compared to CUDA, to be honest. It sounds pretty cool. What stuff do you want to be making in it? Huh. Been rough so far. Yeah. All right. What do I do next? So I guess let's try that projection method. Yeah, I'm not sure where I would start on that. Trying to do an n-body simulation right now. An attempt to move into deep learning stuff, right. OpenCL. Yeah, so 3.0, isn't it? I guess they have like the spec you can look at as one place, but that's going to be probably cut. Chrono specs are just proper terrible usually. They're like super dry. They're all things referencing each other. I guess you can look around for like a tutorial, maybe some. There's an OpenCL guide thing here. But yeah, I don't know. Doesn't seem like it's gone that far, to be honest. Just setting up the OpenCL, that's all it's been doing. Hands-on introduction, a .gov website. Ooh. Yeah, exactly. It's great when you know the thing. That's what spec's for. But yeah. I don't know, if anyone has one, feel free to share some links and stuff. So I think we can project. So I guess when we get making this branch bigger, but here we go. So what we're trying to say is that sort of depth, or that sort of like half dims vector in world space. So we're just doing a rotate and a scale for the ellipsoid. Ah, oh, damn it. Oh, wait. That's just taking the diagonal, isn't it? Of course. That's right, isn't it? Maybe not. let's just do this. The compiler can optimize it. It's a constant anyway. So in the local space of the ellipsoid, it's unit length of 1. So we multiply it with the matrix. That would be the dimensions in world space. So I think we can we project that across. So we would like to produce from the T. So let's just say opaque hit far is now equal to the dot product, well, T near plus the dot product between the ray direction world space and the half dims vector. Yes. So how much does that project across that one? And hopefully that's it, right? Because we need to find some way to optimize it, because otherwise it's going to be painfully bad, because it's going to check over every single ellipsoid, and that's not going to be good. Right. It seemed to have helped, but then I turned to the right and I still see some problems. This is pretty nice. Oh no, but then that is not here. Still has some problems. No. See, our overlaps are all bad. Crap. So that's still not good enough. We could multiply this by like 2. But then you just get into like, cheesing territory. Just fully cheesing it to, it's not really proper solution. I saw a glitch there. Well, I don't know if that glitch was to do with the occlusion. Yeah, I think that's part of the problem. Yeah, so if we look down on these things, there's not that much distance between them. Interesting. No. Right, so I guess let's remove this optimization and just see if that is causing the problem we are witnessing. So we just keep going round and round and round. Okay, so we got rid of that thing. So if we go up and look down, do we witness the same problems? So yeah, we're looking to the right and stuff, I don't see any bugs there. I look down, don't see any problems there. So yeah, it's definitely that early and out stuff. Crap. So yeah, these glitches are fine. One of them, fine, I need to fix them. But they're next on the list. Let's get rid of the glitches. Oh, just turned off the occlusion buffer. So yeah, optimizations. They are hard. So how do we find a far enough away place to exit said we could just say, right, check the next 4 ellipsoids. If you have any more than 4 overlaps, you've got a problem. Still, it's 4 checks. There might be more checks than I want, so maybe there's a way to... Maybe, all right, maybe you say, right, we could test that out, see how good it is, because we've got quite a lot of overlaps in some cases. But it'd be good to see if we could have a sort of a far thing to check. But we could just say ellipsoids count is equal to ellipsoid index plus 4, or some min between itself and the number of ellipsoids, and then just, you know, it's still a bit silly. Right, still problems. So 4 isn't enough there. But then will 8 do it? But then 8's like still... Hey there, Fixable. Hey, I'm trying to make a snake in Raylib and C++. Kind of cool, but hard given it's my first time with Raylib. Awesome. That's great. What's you finding difficult? Are you very new to programming? Or just trying to... or is it the actual game you're struggling with, or is it trying to... or the ecosystem, shall we say, getting C set up and stuff like that? Yeah, it's all these damn problems. Look at these. Oh. So that's with 8. That's quite a lot. So I don't think that's a good solution either. Let's go back to the drawing. Yeah, what could we do to improve? So as soon as you get an opaque hit, and then you get a far, for instance. So we could say if the hits that you've done is further than the longest length of one of your dimensions on the ellipsoid in local space. Oh no, crap, the projection wasn't in world space, was it? The projection... Wait, would it? Oh no, no, it would have been. Yeah, it would have been in world space, wouldn't it? So if we take those 3 vectors, you get the minimum. So if you take all the axes, you take the axes of the Wolfram ellipsoid, you take the axes of the Wolfram ellipsoid, and you take the biggest one and you say if the ray has hit something further than that distance, then we could try that out. So you say plus the maximum square root max length squared, so we avoid the square root, of E world axis 0. Alright, so you take all the axes and you just find the maximum length. I'll clean up the code if this is the solution. Just roll with it. And we square root it, add it to the t near, and just hope for the best. So we early out, we go past that. Current new to radio understanding how to detect collisions with it. Given I have two squares, one is a forward, and one I control the player. Right, I think I know what you mean. It's like a bot. How do I detect if the player collides with the food? I mean food, right. I tried using position of the food. Yeah, you want to look at AABB collision. That should be good enough. It's not too difficult actually. It's just an if statement with like 4 conditions in there. There's plenty of resources for that. AABB versus AABB. You would just need to look for one of these tests. There's this Mozilla one here. It's pretty common. Sorry, my game is open, so my mouse is not clicking. This one does it with a bunch of if checks like this, and it teaches you about it here. I think there might be slightly better ones where you can do some subtractions and things, but yeah, there's this page here as well. I wouldn't worry about the sweeping tests. This one's a little bit more advanced, probably. Yeah, you just want to know if they're collided, isn't it? You don't need the normal. But yeah. You can just look into AUV versus AUV collision, that should do you. Ah, my face. Right, so see if this optimization works. Right, we're still seeing a glitch. Yeah, these guys, right. Still seeing them here. That's not great. Yeah, I wouldn't be too dependent on Raylib for everything. If you can't find it in Raylib, don't bother trying searching too much. If you can't find it in there, just try and give it a quick Google. But I guess you just might not know what the terminology is in AABB, for instance, like an access line bounding box. So I guess that's probably the issue. Maybe they have that in Raylib. Do they have that in there? They have shapes. Collision area. Rectangle. Check collisions rectangle. They've got a function for it, I think. I don't know what a box is. Yeah, box is like it's an ABB. Yeah, they've got... Ah, interesting. They're doing it per pixel. Oh, they draw another box over there with the collision area. So they're able to get a collision rectangle, so like right, I see. Of where it collides. So they've already got an example for this actually. I guess I can link you to this code. But yeah. It's a very simple thing, just implement yourself also. Then you won't be dependent on Raylib. No worries. Yes, this sucks. Problem is there's so much overlapping stuff, and we're going to get this in the real game. So we've got to solve it properly. Hang on a minute. Hang on a minute. I'm being a bit of a twat. I only did this for the first opaque hit. Alright? I didn't do it for the one down here, which is the one where we hit another one and it was closer. So actually, T near far might just be enough. So if the next T near is further than the opaque hit T near far, then we can exit early. So maybe... No, still a problem. No. Especially there. Oh. Alright, so... Right, let's try some more gymnastics. So didn't that one where they just take the longest side, the longest dimension and use that. So yeah, still got problems here. Why? How many are you hitting there? Can I try a T4 on that? Still got some glitches. That's a lot better here, but it's, yeah, still glitches, especially on the edge of the screen. I've got a really high field of view though, which I probably want to like not do. I don't want to test against every ellipsoid in the scene. So what could we do to avoid that? Well, it's not in the scene, right? It's every ellipsoid in the tile. Let's see if we can rethink this. Just do some ellipsoids like that. So here, imagine there's a tile like this. Right, here's the in and right. So the ones that overlap with this tile, let's say they are in the list. And they might not necessarily be sorted. Or is it, you're taking that view space bounding box, it's not good. Because the thing is, right, is you could have an ellipsoid like it's orientated like this. And when you put a view space bounding box around it, the closest depth is this edge here. Even though when you hit it, it's going to be back here. So for instance, you might hit it here. So it's not really there. So you might have another one which is actually closer. But then how could... The bit that I'm confused about is how could... Why are we hitting something which is further away than the T far? Say if it's there. How are we hitting something further, or say if it's here? How are we hitting something which is further away than T far? That is behind, before the one which comes in front. Well, we have lots of overlapping ones. Right, we especially saw it when it was perpendicular. I think that's safe to say. The problem arose most when it was perpendicular. Now, let's go not do this thing, just use T far. When it was perpendicular, we really saw the problem arise. Get rid of the occlusion buffer. So we're really seeing it here. What are we seeing? Well, we're seeing what is that ring? It's the ellipsoid. So this ellipsoid here, this ring is that ellipsoid there, right? That's what we're seeing. No. It is, right? Okay. So this one is technically closer, right? So when you're talking about this one here, so because this one here is technically closer, when we're talking about this pixel here, we've hit it and it's T far. I guess does this happen for a basic one like this? It doesn't, right? Because here's this one on the next level up, right? We're not able to witness that behavior when you've just got two of them like that. The problem is when you've got all of its friends next to it, there's something going on, right? So what you've done is you've hit this, okay, right. This one and this one are probably in the when you fire through this pixel here, it's testing against this one and this one because they are the closest ones along the Z to the camera. And it notices that, yeah, but you won't get a hit here. It's only if you get a hit does it exit. So which ones are that? Which ellipsoids is that pixel hitting? Well, it's only hitting this sort of top this top circular. It's this model here, right? It's got a top one and a flat top one, and then this one which goes down to the bottom, right? So it's hitting this sort of flat top. This pixel here is hitting this flat top. This top here. Right, so the one that it's hitting first. No, but why is it rendering the one? I see what's going on. Or do I? So this pixel realizes that actually so it's returning the shading of this flat top here in this area here in shape of this ellipsoid going down, right? So that's because it probably hits this one first, but very low down. And then it will hit to the T-far. Yeah, so maybe. And then it might hit. Alright, so maybe it hits this one first. I don't know why though. Yeah, maybe this one is closer. This one is probably closer. Then it will hit this ellipsoid here, which takes that shape, right? That will be further, so it will cause an exit. And therefore it doesn't test this one here. So this glitch specifically will show up when you have two perpendicular but long ellipsoids, because that T-far thing will not be enough. So the exit location is not enough. How would you solve that in this one? So I assume you've got one, so that's your first hit. Your second hit would be this one here, but you want the third one to be tested. But you don't know if it is the third one in that case. Awesome. Well, I'm glad we fixed that for you. That's cool. So I guess what other metric could we use? So it's hitting this sort of flat top first. Then it's going to exit when it just finds that one. But fire right through this pixel, right? It's this top first. Therefore it shades of that color. The next one it hits is this one. So I think when you get the hit, you want to say if the center position, or maybe you could say the near. Can I redraw this? So what you want to say is you're already sort of going like that, isn't it? And then we've just got like another one of these going through like that, basically, isn't it? So your camera would say like, hey, this one is closest here, so try to render that one. And then like, hey, this one's the second closest, just because the way the camera is, right? If you used to put a bounding box around it, this one is technically closer than this one with a bounding box around it, right? So that's why it goes in that order. So what you want to say is like, well, I could get the center position quite easily. Can we use that? So if this one hits first, then this one. So we probably don't want to use the hit distances or something. Nowadays, what we're done. Yeah, we don't know if we want to use the hit T's in this. We want to find a position along the ray. Maybe we could mark. If you get the world space bounding box, we can do that. Or maybe you get the local space bounding box in world space. You want to get the sort of like, so along the ray, how would you know? Gotta be careful. So I think, could you get the half extent? So it's difficult to tell because it's in 2D here, but I don't know if it maps to 3D, that's the problem. But I reckon, could you get the half extent? And then mirror it. Yeah, that's the thing you could get, even on 2D it could fail, right? If that's where the half extent goes, or does it? You get those two positions. But really the better one would have been this one. Maybe. Or you get the half extent from the center, you project it across the ray, and you get a point or whatever, right? And you get another point there or something. How's this helpful? So we could do that for all of them. So this is the one that you hit first. It hits here and here. But if you just take, so what you could say is like my exit. Do we care about this exit point thing? Well, we probably care about the T near hit. Well, no, we don't. The T near is kind of pointless. What you're kind of saying is, given my ellipsoid, if I was to put a bounding box around it, or sorry, I was to project the half dims, which I guess is something like that. It's not going to be correct. Not going to be that good, to be honest. Because it could be something like this. Well, no, what the half... It would, wouldn't it? The ones you really want is to get it going like that, but there's so many different vectors you can do. It's like a cube. It's just too many. But you want to get... Say if you could get those 2 points. If the next one that you hit, so you want to get that sort of like furthest point that way, basically, right? When you've got a hit. If the next one that you hit has its closest point is further than your furthest point, then you can exit. Because that's what you're measuring, is the overlap along the ray. Given the full extent of the ellipsoid. So could we... I think it's possible. So the logic would be something like this, but instead of t far, because t far is kind of meaningless, we want to use, so when you hit something that's opaque, you want to use t so you've got the axis vectors. Are we just going to add all those together? Is that silly? Might be. So if you add all those vectors together, I guess we can give that a go. Would it be the add of all those vectors though? So if you have your basis vectors like this, if you add them all together, you'll get the one that goes in between all of them, wouldn't you? Because that will get added to that. That'll get added to that type of thing, isn't it? Something like that. Maybe that's what you need. Let's just roll that. So if we sort of like just get the... I don't know what to call it, let's just call it H. Alright. So given that, this doesn't feel right though. Yeah, you could then flip it the other way. And see, if you project that across the ray direction, I guess I'll just call that HP. So you say dot product with the ray direction in world space and that H thing. So then you could use that and so how does it go across? So from the center position, which would be the translation. So you want to get your sort of far point, I guess. Maybe it'll be the add of E dot translation plus this sort of like HP thing, right? That gets you that sort of far one. Now the near. Wait. I was saying project it across. But you want to do it from like, where is the center position projected onto that ray line as well, and then get sort of that, I guess. All right, so if we added this to that earlier, maybe that'll be it. It seems a bit weird though. So, right. Cool. So when it comes to this sort of like near thing that we're testing, so you still want to kind of do this, but what you're looking for is the kind of one which goes the other way. But you don't know which orientation it is. So it's saying along the ray direction, isn't it? Yes, whereas you don't know which way this half DIMS thing is pointing because it's just been translated like crazy, rotated like crazy possibly. So if you just take those two, for instance, yes, that's what I was thinking about it. And then say if you get this sort of one which goes the wrong way and dot it with that, it gets you a negative value. So you don't, you've got the kind of wrong. Yeah, this doesn't seem... I'm kind of on the right track, but it doesn't seem like the correct... That's too fiddly. But yeah, so if we want to get... Given the bounding box... So if you had those view space bounding boxes, still the depths for those, maybe that's what you would use. We have those still, isn't it? Maybe we can use the T-file thing. That might do it. Right, got me some ideas. So we actually have the depths for those. So the ellipsoid indices, the depth would be stored from is this packed down and it's stored into the sort keys. I think. The problem is it's stored in the sort keys, but you could get it back out, unpack it, and turn it back into something, and then it might be enough. Let's see if we can get these. So sort payload, sort keys. So we just try that out. Sort keys. Cool. So back into the ray tracer. We put that into the low 16 bits, and the way we worked it out. Fixed point. Right, pack fix. So we can do an unpack fixed point. We got that. Okay, so we take that. I think what we can do is we can get the T near. So we extract out what's known as the view space. View B-box view space near. So that will come from the sort keys. Range.start plus E index. Maybe we can pack this somewhere closer so it doesn't have to fetch it from another buffer and only use the lower 16 bits or something like that. We can look into that. Yeah, I think we do an unpack. Boom, that's what we want. So it would have been quantized a bit, so there might be some issues there, but maybe it's fine. So if you use that bounding box and view space, T near. Sorry, the T near. The near part of that bounding box and view space. The depth of that. Near depth. Near depth and view space. I think that's better. VS will look like versus otherwise, wouldn't it? So let's try that out. So if that is greater than the opaque hit far, so in this case here, this line would hit this one, and then it would have hit this one down here. But yes, your opaque hit far would have been this, but then it hit this one here, but then the near was actually all the way up here. In a view space, bounding box is all the way up there. So then that wouldn't end early, giving this the opportunity to be hit here. And that would then, yeah, something along those lines. I don't think that would have been a correct. It wouldn't be closer, but at least gives it an opportunity to be hit, because the problem is if you hit this one or something here, the vector line, the ray line like that, would have been a problem to render. Well, hopefully that works. Right, I'm not seeing any glitches there. Right, let me turn off the occlusion. That seems alright. Right. Oh, this looks alright. Now let's check performance. Because we could have just be, it could just be allowing everything still. But we just, so we run it again, it was 2.5 milliseconds. So let's see what it is with the optimization. 1.75, good. So this seems to be working. Okay, on my days. So this used to be like 2.5 without that optimization, but now we're able to early out. That was a bugger to find. Can't believe I found that. Thought all hope was lost. Alright. So we're getting these sorts of issues here. I would like to think that's the near plane and something. What crap is going on here? This is real bouncy. Well, there's still some issues to look at though. I think the problem here is you've just got tons of ellipsoids that are possibly in the same tiles, and it's just searching over a whole bunch of them, but I don't know why it's noisy. A bit weird to me. We'll probably have something more like this anyways. Just a whole screen filled with it. So there should hopefully be some good occlusion culling going on. But yeah, having full screen ellipsoids is going to be a bit of a problem. We're hopefully not having those. But yeah, I'd like to see if we disabled some of these. If we disable that check, the optimization, do we get that problem? Where it sort of cuts off. Yeah, we do. That's just to do with the near plane or something. That's okay. But yeah, we'll look at the performance on that. Yeah, it's noisy as hell, right? I think it's sorting so many objects. No, that's not the problem, it's the ray tracer. If I pause it, we'll see it's 4 milliseconds. The sorting ain't too bad. The ray tracer is just noisy. I don't know what it is. But it's not that bad. 4 milliseconds is probably acceptable still. Cool, so I guess we got it working for the ray traced anti-aliasing. The problem is we still got this occlusion buffer problem. If we disable the occlusion buffer, the problem goes away. So these are being occluded, these two guys here, for some reason. Don't know why. Right. So the next check would, or the next one we'll need to implement for is for the multi-sample density aliasing. But I guess we can just save those for another time. I would really like to get that fix in for the occlusion buffer, but I guess I don't have time for that. But yeah, at least we got this working today. And the performance isn't that bad. there might be some... It becomes a bit noisy. I don't know why that is. I wonder if this... We could do another little test quick. We can be like, well, if the mouse is at this pixel coordinate, why don't we just print it out? And this will tell us how many ellipses we're testing over. So we have a full screen of them. Is that quite noisy? So it's just a solid 25. Shoot, I just took a damn screenshot. Didn't mean to do that. So yeah, we're only getting 25, but it's a full screen of them. Extremely great, just managed to spawn new food box in a random position after collision with the player. Very nice, awesome. Cool, well done. Hey, have you got the snake moving yet? Yeah, so that's about 5 milliseconds. So it seems like worst is 7. Sorry, best is 7. Overall frame, sorry. And then worst is 9. So it seems best is 4 milliseconds for the ray tracer, then we saw about 5 on it. So, yeah, a little bit noisy. I don't know what's going on there. Maybe it's competing with OBS or something. So when the frame gets longer, maybe it starts competing with OBS. I don't know, just a guess. But it could be my code. It's just easy to blame someone else's code, you know, this is the way. So yes, it's only 27 though, in a... And it's that expensive. But we're not even testing over all 25, shall we say. We're testing over... Yeah, we're not even testing over all those 25. We should be testing over less of them. Because we've got this optimization here. So how many did you actually go over? It's a good question. Or we can see that just by writing that out. Right, it's not even exiting there. So it tests over all 25. In this case, but that's because we have a lot of overlapping ones. Ah. Rightio. Yeah, so overlapping ones are a bit of a bugger. But you know, so the reason why it's fine like this is and runs okay at 1 millisecond is because we don't have a full screen worth of them, but as soon as we do this, where we have a full screen worth of them at kind of this in between 1080p and 4K, we end up getting this somewhat noisy thing where it's about 3 milliseconds here for, and then this one's about 4 milliseconds. Oh, nearly 5. So about 3 milliseconds to about 5 milliseconds. So that's, yeah, a whole 2 milliseconds difference for some reason. I don't know whether that's is the occlusion buffer having to play in that. No, I turned off the occlusion buffer and it's still very noisy. very consistent, the number of store entries we've got. It's like 200 odd thousand. Yeah, I'm not sure what that is. Right. So I guess it's good progress. We've at least got the glitch that's gone. Like this is like a mid-tier card. And we're trying to push above 1080p on it. So maybe it's, say we resize to 1920 by 1080. That's basically it there. So this is 1080p. Get a full screen. One of them. Right, that's about 2 milliseconds there for the render. Full screen worth, you know, that was 25 in a tile. So it actually the performance doesn't seem too bad there, thinking about it. If I turn on the occlusion culling, which is not really helping us out at the moment, that adds very negligible as well. So yeah, it seems like that's just the cost of trying to push a high resolution on a mid-tier card. So this probably seems acceptable. We've got to see with the full scene still. But this seems, I seem quite happy with this, to be honest. So I don't know how much I want to go into and fix the other renderers now, because this is the problem. I've got 2 more renderers. I've got a multi-sampled anti-aliasing render, and I've also got a super sampled anti-aliasing renderer. But I guess because we've solved the problem, we can easily solve the problem in those ones, I think. They're a little bit more complicated than those ones. They've got hit lists as well. When we did this hit list thing, they've got it. But they haven't got... Yeah, they've got this hit list things, but they're a bit more complicated. Like the multi-sampled anti-aliasing, you know, it's all in software, isn't it? We generate the hit list, but there's like a deduplicated set of hit lists. And, you know, there's subpixels, you know, you over all the subpixels, they have their own hit list, but you deduplicate them, you know. And then you basically have a weight. If it's a duplicate, you up the weight. And then you process all the samples. Oh, the game crashed. That's understandable. And then afterwards you do all the material samples for all the unique hits of each ellipsoid, basically. And then you go over and do all the combining. So it's quite well optimized, as in it tries to minimize the amount of samples that you do across all of the subpixels that hit the same ellipsoid. So there's a lot of complication in here, so I think we've just got to figure out. So when we generate the hit list, this will do this doesn't care about what you hit in what order. This just does the shading for it. But I guess you'll shade stuff past an opaque hit sometimes, because yeah, we try to early out here based on the accumulated alpha, but things are not sorted correctly, so you would get rid of that optimization basically, and you would overshade. But it's okay because you've only got 4. We're only allowing 4 hits per array now anyway. So that should be fine. And then you could probably do the sorting code here that we had in the other one. And then you just index here. So yeah, it should be okay. And then I guess for the super samples anti-aliasing, which is kind of the same, but we don't do any optimizations for it. We just go over every subpixel and do the ray tracing again. So I guess, yeah, this one I could put this one. So, right, let's say next stream we'll do these two. This should be quite easy because we've already found the solution. And then hopefully we're gonna have some time to fix that occlusion buffer problem. Because yeah, it would be nice if we had it properly working, and maybe we can try and verify it by like it actually works fine. We saw that we was able to switch to a view where we could see what was being occlusion cold and got rid of. We made a temporary view for that, but it wasn't quite. Yeah, but for some reason there's a bug. So it'd be good to verify it actually works somehow. But yeah. So that'll be on Sunday. About 4.5 hours ago, but on Sunday. Let's see what else is there on the to-do list. So yeah, we'll do those things. So we've been trying to fix this overlapping Z-fine thing. This is what we're pursuing at the moment. Transparency, I guess we've implicitly done that, but we've not tested it. This is the issue. So I wonder, we could try and test a transparent object. We'd have to add more of those models though. So I guess we could do transparency afterwards. So next week we do transparency and maybe test in a whole load of model instances and just blasting them out and just check what performance is like, maybe. And see how we're going there. And maybe we can look at trying to fade out some smaller ellipsoids or something. Because there's no point rendering stuff that's too small. So yes, yeah, we'll work on these things next week. After Sunday. And then the last 2 weeks will be on rendering to HDR and throwing a tone mapper in there. So we render to a full high dynamic range texture. So that's not sRGB, you know, it's a full 16 bits per channel rather than 8 bits per channel. Tone map at the end, so it goes out to a standard. Wait, what did I call this again? High dynamic range. Yes, a standard dynamic range. Something like that. I think that's what it stands for. So you compress it down to sRGB basically. And then because we have HDR, we'll be able to do a bloom. So the last 2 weeks would be of the month would be on that, hopefully. Yeah, exciting stuff coming ahead. So we actually get some bloom which pops and, you know, looks bright rather than just changing the color of the object. So yeah, that's what we got going on soonish. Let's go and raid Artie. All right. Thanks for coming, everyone. I hope you have a good weekend. Come and join the Discord in the meantime if you want to come hang out and chat about things. Anyways, it's been good. Have a good one, guys. Bye-bye.